In case of a machine revolt, the hardest thing to do will be escaping from four-legged robots. Meet the top 10 smartest, fastest, and most agile four-legged robots of the future. Here we go! In 10th place is the research robot Doggo. The main advantage here is low cost, less than $3,000. The robot was developed by Stanford University students with a fully open source code that allows anyone to assemble their own doggo. At the same time, the robot has good leg construction and design engines that provide more torque than the Minotaur from Ghost Robotics, which cost $11,500. This allows Doggo to jump to a higher altitude even than the Cheetah 3 from MIT. In 9th place is the ANYmal robot from Deep Robotics. This robot knows how to charge itself and go to the charger just like your robot vacuum. But this isn't the most surprising part. This robot, weighing 40 kilograms and 65 centimeters high, is able to jump over a hoop, hit a ball in the air, and land on all four legs. The ANYmal's ability to jump 1.5 meters in length and 40 centimeters high can allow it to go over obstacles and move around in any terrain type, independently navigating the space on its own. In 8th place, Skaterbot from the Swiss Higher Technical School in Zurich have designed the robot. The developers provided it with information only about how the skate blade behaves on ice. Next, the robot itself knows how to move better and developed its own wave-shaped gait, which allows him to move straight or turn in any direction. The development goal is to demonstrate the engineer's computationally controlled approach to optimizing the design and synthesis of movements for robotic creatures. With this approach, you can create any robot and it will learn to catch up with you. In 7th place, Minotaur by Ghost Robotics. The robotic's unique feature is that the feet are directly connected to electric closed-loop monitors, so Minotaur recognizes surfaces with different characteristics and adapts its gait to them. This direct drive also allows the robot to make fast and difficult movements while jumping, squatting, climbing a grassy slope, or overcoming large rocks and cross obstacles. If this symmetrical robot falls on its back, it will just stand up and go further without turning over. A 6-kilogram robot can carry 3-kilogram loads, jump almost 50 centimeters up, and reach speeds of up to 2 meters per second. Sixth place goes to two robot pets at once from Unitree Robotics. The first one is Lycago. At a height of 60 centimeters and weighing 24 kilograms, this robot can work 4 hours on one charge and carry a load of 7 kilograms at a speed of up to 0.8 meters per second. The robot can be controlled remotely, but it can also operate autonomously if equipped with cameras, GPS, LiDAR, or other sensors. In any mode, the robot can adjust the course, tilt and roll the body of itself to maintain balance. So far, the Lycago, which costs around $45,000, is mainly purchased by universities, but the version of Lycago Pro is designed for patrols, delivery, hazardous environment research, and searches. This new generation of robots are able to work together, such as carrying an adult, pulling a minivan, or playing a game of tug-of-war. But Unitree is already developing a new and improved robot at the same price. ANYmal is lighter than Lycago, plus it has more powerful processors and a built-in computer vision system. The robot legs are attached to the casing via 2 electric drives, and another motor is mounted between the leg segments. This allows the robot not only to move forward and backwards, but also to lean hard enough in the desired direction. Coming in at 5th place is the Mini Cheetah from MIT. It's a small, clever 4-legged robot that can run and do backflips. It's rugged and has powerful actuators. Developers even claim that it is virtually indestructible. A wide range of motion in each joint and high speeds, high torque drives enable the robot to perform extremely dynamic maneuvers. This robot, which is 30 centimeters high and weighs around 9 kilograms, can move at speeds of almost 9 kilometers per hour. Additionally, the version 3 of Cheetah is capable of jumping in rough terrain, climbing stairs dotted with debris, and quickly regain balance when it's jerked, pushed over, or being blinded. The robot is designed to not rely on cameras or external environmental sensors. Instead, it relies on 2 algorithms, a contact detection algorithm and a model prediction algorithm. The former continuously calculates the best position for each leg based on data from gyroscopes, accelerometers, and leg joint positions. The second one predicts the further development of the situation. By combining both versions, we obtain an indestructible robot capable of moving even blindly. In fourth place is the ANYmal robot. Developed by researchers at the IIT Institute based in Genoa, the robots are famous for being able to tow a Piaggio P180 Avante aircraft weighing over 3 tons by 10 meters. In the future, the ANYmal should become a fully autonomous 4-legged robot capable of moving freely in rough terrain. The robot is 90 centimeters high and weighs about 130 kilograms. It's equipped with 4 motors and 2 computers for vision and control. Thanks to its Kevlar shell, the protective mesh of aluminum, as well as the use of plastic and fiberglass, this robot is very robust. For better grips, the legs are covered with rubber, and the hydraulic system consists of 4 electric motors that rotate hydraulic pumps and create pressure in the system. In third place, the Centauro project. It's no longer a robot, but a robo-centaur designed by researchers from the same IIT for rescue operations. The robot, which is 1.5 meters tall and weighs 93 kilograms, is characterized by its high drive power and high structural strength, enabling it to break bricks and boards. The robot can move in complex environments. The IIT Italian Institute of Technology include semi-destroyed buildings and used unmodified human tools to solve complex problems. This robot is controlled intuitively through an entire body telepresence suit, which provides visual, auditory, and upper tactile feedback. What the robot sees and wants to do will be displayed to the operator with elements of augmented reality. In this case, the robot will be able to conduct simple operations in the future and on its own. The robot is made of light materials such as aluminum, magnesium, and titanium with plastic shells and 3D printing. Inside, there are 3 computers that control the perception, control, and planning of motion, as well as a battery that lasts 2.5 hours. Centauro's legs have 6 degrees of freedom, and the robot can take different configurations as the wheels allow the robot to either ride or walk. Coming in at second place is ANYmal. This is a rugged, standalone, 4-legged robot designed for inspection and manipulation tasks with a highly integrated, modular, AnyDrive robotic coupling drive. The ANYmal is equipped with sensors such as LiDAR, stereo cameras, and GPS, and this allows it to independently navigate in industrial sites, power plants, underground systems, and other unusual environments. ANYmal can move around on its own with rugged terrain, see, hear, and touch. This allows the robot to determine the exact air temperature, pressure, gas content, and soil conditions, analyze sounds, and search for objects. For example, ANYmal can check if a fire extinguisher is in the right place. The robot is also able to open doors, dispose of waste, and press buttons. For example, like in an elevator with an additional grip lever. Interestingly enough, the developers want to give ANYmal the opportunity to run away from the abusers. Unlike Boston Dynamics robots, which humbly carry all the bullying, with the help of machine learning, robots can learn how to find the best ways to perform different tasks. For example, to run away from the abuser twice as fast as before. Simply put, the training allows the robot to think and learn like any animal whose actions are subject to internal logic. Also, ANYmal, which is only 70 centimeters tall, is able to walk at a speed of more than 3.5 kilometers per hour, overcome obstacles and ladders, carrying loads of up to 10 kilograms. He also knows how to dance and skate on rollers. Recently, a waterproof version of ANYmal C was presented. The robot received a full-fledged housing and protection from water according to IP67 ratings and a new built-in sensor for navigation. For processing, information sensors and other calculations are responsible for a computer with 2 6-core Intel i7 processors and another dual-core Intel i7. In addition, the top part provides an interface in which you can connect to the robot board NVIDIA Jetson AGX Xavier. This robot is commercial, but its price is still unknown. And finally, coming in at first place is the smart and characteristic Spot from Boston Dynamics. Spot can move around almost any place while feeling the environment. Payload compartments allow for Spot to add up to 14 kilograms of additional equipment on the robot's back. One of the accessories that Boston Dynamics plans to offer is a lever with 6 degrees of freedom which allows Spot to capture objects and open doors. Spot's hardware is almost completely custom designed. It includes powerful processing boards for controls as well as a sensor module for perception. Each module consists of a pair of stereo cameras, a wide-angle camera, and a texture projector that enhances 3D in low light. Sensors allow the robot to use navigation methods known as SLAM, or simultaneous localization and display, to bypass autonomously. Besides autonomous behavior, Spot can also be controlled by a remote operator, but even in manual mode, the robot still has a high degree of autonomy. If there's an obstacle ahead, Spot will bypass it. If there are ladders, Spot will climb them. Spot's legs are powered by 12 non-standard DC motors, each of which are designed to provide high torque. The robot can move forward, sideways, and backwards, run at speeds of 1.6 meters per second, and dance. Today, no major robotic event takes place without a Spot available for rent. From DARPA Subterranean Challenge, where it helped the team win the competition, to the TechCrunch Robotics AI. Subscribe to the channel and like the video. Hey, let us know down in the comments which robots you want to see next.